So let's now turn our attention to measures of aerobic capacity, also known as aerobic power. And this is simply defined as the ability to perform large muscle, dynamic, moderate to high intensity exercise for prolonged periods of time. So some examples here would be running, cycling, and so on. Again, utilizing large muscles, perform moderate to high intensity for long periods of time. This ability to perform these large muscle dynamic exercises for long periods of time depends heavily on the integrated physiologic and functional state of both the cardiorespiratory as well as the muscular systems. Looking at this diagram here, we all know that we inhale oxygen-rich air. This O2-rich air travels down to the lungs, and it's within the lungs there's a exchange between the air in the lungs and the blood traveling through the lungs of oxygen and CO2. So what we have here is that oxygen in the lungs is basically being transported or diffuses into the blood, and this oxygen-rich blood is then transported or pumped via the heart through the vascular system to all cells of the body. Within skeletal muscle, particularly during exercise, exercising muscle uses oxygen. The muscle fibers contain specialized organelles called mitochondria that utilize oxygen to produce energy in the form of ATP. As a result of this, the byproduct is CO2 production. This is referred to as oxidative phosphorylation or aerobic metabolism. So this oxygen-depleted CO2-rich blood now has to be returned back to the lungs in order to pick up more oxygen and give off CO2. So within the lungs here, this oxygen-poor air that's CO2 enriched, we have basically diffusion again of CO2 out of the blood into the lungs, and then exhalation of that CO2, and simultaneously we have diffusion of O2 from the lungs back to the blood. And again, this cycle repeats itself over and over and over again providing oxygen that's utilized to produce ATP as a fuel source for exercise. So essentially, aerobic capacity represents the rate at which energy in the form of ATP in the body is provided from aerobic metabolism, also known as oxidative metabolism or oxidative phosphorylation. Now, if we talk about the maximal rate at which energy is provided from aerobic metabolism, we call that maximal aerobic power, or more commonly, VO2 max. So VO2 max is the gold standard measure of aerobic capacity, aerobic power, represents the highest oxygen uptake that an individual can obtain during sustained dynamic exercising using large muscle groups. So a VO2 max test is typically performed in a laboratory on a treadmill or a cycloergometer. The subject is hooked up to our metabolic cart that you see down here. And essentially, breath by breath, we're measuring their oxygen consumption and CO2 production during increasing intensities of exercise. Now, if we plot oxygen uptake or oxygen consumption against exercise intensity down here in speed, we see this linear relationship. With increasing intensity, we see a linear increase in oxygen uptake up until essentially what is known as VO2 max is achieved. And with VO2 max, a further increase in exercise intensity does not lead to a further large increase in one's VO2 or oxygen consumption. And we know that with training, VO2 max increases relative to pre-training levels. Now, it's not common for everyone to have a metabolic cart. These are very expensive and primarily dedicated to laboratory use. Therefore, a person's aerobic power, aerobic capacity can be estimated via a number of submaximal as well as field tests. So these are performed outside the laboratory typically. These include a 1.5 mile run, so basically covering 1.5 miles on a track as quickly as possible. 12-minute run, which is covering as much distance as possible within 12 minutes on a track, and something known as the yo-yo intermittent recovery test, or more commonly referred to as the BEEP test. These are all considered other measures of aerobic capacity. So if you're unfamiliar with the VO2 max test, here's a short video that you can watch on your own of this incremental exercise test. And you can see the metabolic cart over here. The subject is running on the treadmill at increasing speeds and increasing incline until what is called volitional exhaustion. So basically they end the test. And again, the goal is to have them work at as hard as they can in order to determine their VO2 max. This table is showing VO2 max descriptive data for athletes in various sports. I'm not going to ask you to memorize these values, but you should be aware that those athletes that are more of the long distance endurance athletes that participate in cross-country skiing, middle distance running, and long distance running, for example, you would expect them to have higher VO2 max values compared to many other sport or athletes. So if we look at just kind of what is considered above average here for both men and women, above average is about, low to mid 50s, and this is in milliliters of oxygen per kilogram of body mass per minute. So low to mid 50s and kind of mid to upper 40s for females, and you can see some of the sports associated with having an above average VO2 max. And if we look at, again, we talked about the extremely high, but looking at very high, we see particularly long distance cyclists, rowers, and race walkers that have been shown to have what are considered very high VO2 max values. So you can kind of pick your sport down here, what are considered average you see down here, kind of the mid 40s to maybe low 50s for men, and mid 30s to low 40s for females would be like baseball and softball players, American football players, shot putters, discus throwers, Olympic style weightlifters, as well as bodybuilders. So you can just see a range here of different sports and different athletes and what a typical VO2 max value is for those athletes. All right, the next measure of athletic performance, known as agility. And agility is simply defined as the rapid whole body change of direction or speed in response to a sports-specific stimulus. And in terms of a sports-specific stimulus, that may be something as simple as just a whistle. So this t-test is a measure of agility. So let's look at the t-test here. The athlete would start here at cone A. When the whistle blows, they would sprint 10 yards to cone B, shuffle left 5 yards to cone C, shuffle right all the way to cone D, so covering 10 yards, shuffle left again 5 yards to cone B, and then backpedal as quickly as possible 10 yards to cone A, and then the watch stops. So let's watch this short video of this t-test in action here.
The agility t-test is a test that can be easily administered in both a clinic or outside space if available. It is a test that has been extensively studied in the literature and is useful for both our basketball, soccer, and football players. John's going to go ahead and demonstrate this test. To perform this test, first place on 4 cones.
All right, so starting at cone A.
The cones are going to be placed approximately 10 yards from each other, and 5 yards out from that center cone is the other 2 cones. John is going to go ahead and sprint forward 10 yards, sidestep 5 yards to one side, sidestep 10 yards down to the next, before returning with a sidestep to the center cone and a backpedal sprint to finish. Make sure you're timing your athlete during this test.
All right, so hopefully the coach in red would be timing, sprinting 10 yards, cone B, left to cone C 5 yards, right to cone D 10 yards, left to cone B 5 yards, and then backpedal for 10 yards, and then stop the timer. All right, another agility test, appropriately named the Pro Agility Test, sometimes referred to as the 20-yard shuttle test or the 5-10-5 drill. With this test, the athlete is starting here in the center. This is typically done like on a football field that is marked off. Maybe you have cones out on the football field to show the athlete where they should be turning at. Athlete would start here in the starting position, sprint to their left 5 yards, touch the line, sprint to the right 10 yards, touch the line, and then sprint back to the left 5 yards, and then the timer would stop right here when they return back to the starting position. So watch this in action here in this short video.
The Pro Agility Cone Drill is also known as the 5-10-5. The cones are marked off in a straight line, each 5 yards from the next, at a 0, 5, and 10-yard mark.
Sprinting to the left,
The
5
athlete
yards,
straddles the middle
touch
cone
the
with
line,
feet and
sprint to
hips
the
shoulder
right
width
10
apart.
yards,
The athlete should keep the
touch
center
the
of
line,
gravity low
sprint back
with a
to
slight bend in the
left, 5
back.
yards, and then
The
time
athlete
stops.
turns and sprints to the left 5 yards, touches the cone or line with the left hand, and then turns back around
Assessing
and
that
sprints 10
rapid
yards to the
change in
cone on the
direction
opposite
of
end.
agility.
The athlete touches that cone or line with the right hand and turns around a second time and sprints through the starting point.
All right, so that is the Pro Agility test there.